Hi, and welcome back to the Implementing and Administering Cisco Solutions CCNA 200-301 video series course by EC Council. This is Domain 2 Network Access, and my name is Glenn Singh. In this video, we'll take a look at understanding the need for Inter-VLAN routing. So let's dive on in. In the previous videos, we look at creating a couple of VLANs, let's say VLAN 10 and VLAN 20. Natively, these VLANs will not be able to intercommunicate with each other. They are totally and logically isolated. In other words, each VLAN is an isolated network by itself. So if you have two VLANs, let's say like from our previous example or our previous lab, VLAN 10 and 20, these VLANs will not be able to exchange any sort of data or network traffic between each other, simply because they are logically segmented. The process of inter-VLAN routing involves a router, which is uses a single interface, simply to allow one or more VLANs to intercommunicate. During the process of inter-VLAN routing, we have to create what we call sub-interfaces on a router. A sub-interface is simply a logical interface that exists within a physical interface. So imagine each router has physical interfaces, and we are going to take only one physical interface and create multiple logical interfaces. These logical interfaces are known as sub-interfaces. Each of these sub-interfaces will be used to transport a unique VLAN traffic. So let's say, for example, we have VLAN 10 and VLAN 20. Therefore, we will need to create two sub-interfaces. One interface or one sub-interface to transport VLAN 10 traffic, while the other sub-interface will be used to transport VLAN 20 traffic. To perform inter-VLAN routing, you can use a router or a layer 3 switch to perform this action, as the layer 3 devices are able to interconnect two or more different networks, simply because a VLAN belongs to a single logical network. To get a better idea how inter-VLAN routing works, let's take a look at this diagram. Here we can see we have three different devices. We have PC1, PC2, and PC3. But notice carefully that each of these devices are located on a unique VLAN, and each of these VLANs are on a unique IP subnet. So what is the overall configuration? Well, on fast Ethernet 0/1, we configured VLAN 10, so this port is an access port. On fast Ethernet 02, we configured this interface with VLAN 20, and it's an access port. Fast Ethernet 03, we configured it with VLAN 30, and it's also an access port. So right now we have one switch, but we have multiple VLANs. So how does the inter-VLAN process work? So to put simply, we have to use a method called router on a stick. The router on a stick method simply means that we will require one router, such as R1, and we are using only one physical interface that is connecting the router to the actual switch. This interface is a trunk. So how exactly does the inter-VLAN routing process works? So first of all, we'll need to log into the router, and we'll have to access Gigabit Ethernet 0/1. In Gigabit Ethernet 0/1, we'll create three sub-interfaces. So here are the name of the sub-interfaces. Gigabit Ethernet 0/1.10, and this interface here will contain the default gateway for VLAN 10 devices. So let's say, for example, that PC1 has an IP address of 10.0.0.3. If PC1 wants to communicate with another network, PC1 will require a default gateway. And in this case, Gigabit Ethernet 0/1.10 will be the default gateway for all devices that belong to VLAN 10. Likewise for VLAN 20 and VLAN 30. This will simply allow all the traffic, so let's say PC1 wants to communicate with PC2, how the traffic will flow. So this is what will happen. PC1 will send its traffic to the switch. Once the traffic enters fast Ethernet 0/1, the traffic will be tagged with VLAN 10. This traffic will then be sent up to the router via Gigabit Ethernet 0/1.10. The router will check its routing table to determine how to forward this traffic. The router will see that PC2 belongs to VLAN 20, and therefore the router will send the traffic back down Gigabit Ethernet 0/1.20. So it's not using the physical interface, but it's using the logical interfaces that exist within the physical interface. So therefore it will come back down the same trunk interface back to switch 1. Switch 1 will see that PC2's MAC address belongs to fast Ethernet 0/2, therefore forward the traffic to PC2. And that's how the inter-VLAN routing process actually works. These are some guidelines that you should use when you're going to configure inter-VLAN routing. The switch port must be configured to be a trunk. So what does this mean? So let's take a look. The switch that connects to the router, this interface here must be configured as a trunk. The second guideline, create sub-interfaces on the router. For every VLAN to exist, create a unique sub-interface for that VLAN. Ensure that after you have created the sub-interfaces, configure the interface to operate on a specific VLAN or to accept or transport specific VLAN traffic. Don't worry, we will take a look at configuring this in a lab within a few minutes. Next, ensure that you assign an IP address to the interface. A good example is the sub-interface should contain or should be the default gateway for each VLAN. Next, turn on the physical interface of the router. By doing a no shutdown on the physical interface, it will automatically apply a no shutdown, as in to turn on any sub-interfaces. So now, let us continue where we had left off from the previous example. If you recall, this was the same lab topology that we have been working on for the past two videos. The first instance, we created VLANs and we created access ports. We assigned the VLANs accordingly to each access port. In the last video, we took a look at setting up inter-switch connectivity, where we created trunk links between each switch to allow multiple VLAN traffic to be transported through these links. In this video, we are going to perform inter-VLAN routing, so we'll be working on this portion of the lab today. The first thing we are going to do, we are going to log on to switch 2, and we are going to configure this interface, which is Gigabit Ethernet 0/1, to be a trunk to transport all VLAN traffic. Next, we'll log into the router. We'll create multiple sub-interfaces under Gigabit Ethernet 0/1. So right now we have 3 VLANs, 3 data VLANs. So we'll create Gigabit Ethernet 0/1.10, Gigabit Ethernet 0/1.20, Gigabit Ethernet 0/1.30. And each one of these sub-interfaces will contain the default gateway for these subnets across here. So therefore, if PC1 wants to talk to PC3, the traffic will flow like this. So let's dive in. Now, let us log into switch 2 and go into interface mode for Gigabit Ethernet 0/1 and make it an overall trunk, like so. So now that we have statically configured Gigabit Ethernet 0/1 to be a trunk on switch 2, our job is done on switch 2. So now let us move on to router 1 and create the sub-interfaces. So let's first create a sub-interface for VLAN 10, which is a staff network. To do this, we are going to use the command interface gigabit ethernet 0/1.10, like so. And notice we have a new sub-interface created. The next step is to ensure that this sub-interface only transports VLAN 10 traffic. To ensure this happens, we are going to use the command encapsulation.1q10, where 10 is the VLAN ID. Please note that this command is very important. This 10 value here ensures that this interface only transports VLAN 10 traffic only. This 10 across here is used to create the interface identifier. So ensure that the encapsulation.1q command is very accurate. If you make a mistake, let's say you put VLAN 20 here, so let's say you do encapsulation.1q20, this interface will only transport VLAN 20 traffic. So what we tend to do as a recommendation, we try to keep our naming convention consistent with our configuration as well. So when we are doing troubleshooting, we can quickly identify that 0/1.10 is associated with encapsulation.1q10 as well. So now let us assign the default gateway for VLAN 10. And just like that, we created a sub-interface. We assign the interface to only transport VLAN 10 by using the encapsulation.1q10 command. We assign an IP address. Next, let us create our two other sub-interfaces for VLAN 20 and VLAN 30. So now we have just created our three sub-interfaces. Let us turn on all the sub-interfaces on this physical interface, simply by doing a no shutdown on the physical interface, like so. Let us verify that our sub-interface exists and the IP address is available together with the sub-interfaces in a up state. We will use our favorite command, show IP interface brief. And here we can see our three sub-interfaces created. Each sub-interface has their own IP address and the status is in an up state. So let us test connectivity between PC1 and its gateway, and then we'll test connectivity between one VLAN to another VLAN. To do this, let us click on PC1. desktop, command prompt. Let's do an IP config to verify PC1 has a valid IP address. We can see PC1 has an IP address 10.10.10.2. Its default gateway is already pre-configured 10.10.10.1. So let us do a ping connectivity test to its default gateway, like so. As we can see, PC1 is able to reach its default gateway. Now let us try to ping PC2 from PC1. PC2 is on a totally different VLAN, which is VLAN 20, and it is on a different IP subnet. So let's see if we have end-to-end connectivity between one VLAN to another VLAN. We get a request timeout and boom, we have connectivity. Let's test one more time. Simply because this here for request timeout, it means that ARP took a little too long to respond. So now that ARP has responded, we get successful replies. Let's ping one more time to verify full end-to-end connectivity. And there we go. This here is validation that we have inter-VLAN routing. What we can also do is use a trace route command. On Windows, it's called traceRT. On Linux and even Cisco devices, it's called trace route. So let's perform a trace route from PC1 to PC2 to validate the path the packets are taking from PC1 to PC2. As you can see, the first hop is PC's one default gateway, and the second hop is the actual destination. So this is validation that all the message that going from PC1 to PC2 is going through the actual router, simply because this IP address exists on the router itself. Now let us take a look at the configurations on the router once more. Let's take a look at the show running config for the interfaces. And here we can see each of the sub-interfaces and their corresponding IP addresses. Ensure that whenever you are configuring a sub-interface, you use the command encapsulation.1q before inserting an IP address. Once you have a sub-interface, most likely the Cisco iOS, the operating system, will not allow you to insert an IP address without actually using the encapsulation.1q command. So to validate our configurations, one favorite command we can do is our show IP interface brief, which you saw previously. Another command is a show running config. And the third command, we'll take a look at doing the show IP route command. This here is a routing table. The command we did is show IP route. In the routing table, we have destination networks. So all of these networks are destination networks. And if we read each one, so for example, we have C, which is a directly connected network. The destination network is 10.10.10.0/24, and it is directly connected, or in other words, it is located on gigabit Ethernet 0/1. So this means if the router receives a packet for 10.10.10.0/24 network, the router is going to check its routing table from top to bottom looking for a possible match. In this case, if the destination network is 10.10.10.0.24, it will be like, hey, well, the network exists within my routing table. Let me stop and read the actual entry. The entry says that it is directly connected. In other words, this network is located or living on the gigabit Ethernet 0/1.10 interface. Therefore, the router will forward a packet out of this interface here. The same would be done for the other networks that you see here. So having completed this lab, you have learned how to configure Inter-VLAN routing using the router on a stick method to simply allow multiple VLANs to intercommunicate with each other. Be sure to save your lab and you can play around more with it, create more VLANs and perform Inter-VLAN routing. Sometimes when you configure VLANs or Inter-VLAN routing, things may not work as expected. These are some troubleshooting guidelines that I recommend. Always check the IP addresses on all your devices. Check the IP addresses on the router, the sub-interfaces. Check the IP addresses on your end devices as well. Be sure to perform ping tests to ensure you have end-to-end connectivity. If for some reason that you are not able to ping a particular VLAN, perform a traceroute. The traceroute will simply allow you to see where the packets are dropping. And where the packets are dropping, you can use that point to start your troubleshooting moving forward to the actual destination. Also ensure the VLAN assignments are configured properly on each switch ports. Check for the native VLAN mismatch, which you have seen in previous videos that it can cause latency and packet loss. Be sure to check the trunks for any allowed VLANs. If a particular VLAN is missing, remember the trunk will not be able to transport a VLAN that is not existent within the allowed list. Additionally, check for the trunk mode in case there's any sort of mismatches. These are some additional commands that you can use to validate that things are working properly. Use a show IP interface brief command. This will show you a summary of all your interfaces and the IP addresses and their status. Use a show interface trunk to verify the interfaces which are in trunk mode, the allowed VLANs and the native VLAN configured on the trunk interfaces. Use a show interface followed by the interface ID switch port command to check the administrative and operating state of an interface of a switch. You can also use a show interface sub-interface ID on the router to simply verify the encapsulation mode and VLAN ID of the sub-interface. You can also use a show running config command to verify the configurations applied on the sub-interfaces. In this video, you took a look at implementing Inter-VLAN routing using the router on a stick method. You also learn how to verify and troubleshoot various Inter-VLAN routing issues and how to successfully use the troubleshooting commands. In the next video, you will learn how to configure and verify Layer 2 discovery protocols. I hope this video has been informative for you, and I hope to see you in the next one.